Greetings, ladies and gents, and welcome back at Same Maths and Science Club. Today we are starting what I call the Pythagoras trig type question. So I'm sure this is, of course, a correct name for that, but unfortunately, I couldn't find one. So this is when, of course, we are, trying to where this is where they give you a certain information, and then they require you, of course, to work using diagrams. I'm sure you've encountered this in grade 11s. So we're just gonna dive in using the questions that I have drafted. Of course, you can hit pause, you try them out, and then you watch the solutions. Now they say if 10 of theta is equals to 3 over 4, and theta is an element between 180 and 360, so that would be, of course, in this quadrant, because we know that this would be, of course, 0 degrees, that would be 90, and that would be, of course, 180, and that there would be 270 degrees. So they say, of course, theta is an element between, of course, 180, so between 180 and 360, so it can either be, of course, in one of these two quadrants. So it can be in the third, or of course in the fourth. And one thing again that we must look at, they say 10 of theta is equals to 3 over 4. So that's positive at 3 over 4. And we know that 10 is positive, of course, on the third quadrant. So this is where we're going to draw, of course, our diagram. So this would be, that's how the diagram would look like. Of course, that's a 90 there. Now, so this would be where theta is. Now, what they say that the 10 of theta is equals to 3 over 4. So again, of course, the 3 would be the opposite side, which is, of course, this portion here, which is that length there. And of course, that 4 would be the adjacent, which is right there. But what you can note is that, of course, an x on that region is negative. So that actually, I'm just going to put it a negative there. But also we know that y on this, of course, that region down there, that's it is negative. And of course, we know that, of course, negative 3 divided by negative 4, of course, that's going to give us a positive, of course, 3 over 4 there. Now, of course, what we don't have right now at the moment would be the hypotenuse. So in this case, to find that length there, we just use the Pythagoras theorem, which says r squared, which is what we are looking for, would be x, so it would be negative 4 squared, plus of course y squared, which is negative 3 squared. And of course, if you put that together, 9 plus 16, that would be 25, and the square root of 25, that would be plus or minus 5. But we know that the hypotenuse is always positive, so that would be 5 there. So the hypotenuse in this case would be 5. Now they say determine the value of each of the following without the use of a calculator. So in this case, what they want is the value, not theta. So what they want is just the ratio that you get. So in this case, they say the ratio of they say the value, of course, of sine 2 theta. Now we can note, now what they gave us here, we have theta, not 2 theta, but you can note that that's actually a double angle identity for sine. So this will change to, actually, let me just take another pen. So this would be actually 2 sine of theta multiplied by cos of theta. So that's the value that you are going to get. So that's the identity, of course, when you expand it, of course. So this would be 2 sine of theta. Of course, sine, we know that's the opposite. So the opposite in this case would be a negative 3. Of course, the hypotenuse, we say that's a 5. We multiply that by a negative 4 over a 5. And of course, so 4 times 3, that's 12. And of course, 12 times 2, that's 24. So this would be, of course, 24. And now remember, negative and a negative give us a positive, right? So this would be 24 divided by, of course, that would be 25. 5 multiplied by 5, that would be 25. So that would be the value of of sine squared of sine 2 theta, rather I should say. So they say, so for B, they say they want the value for cos of 2 theta. Again, you can notice what that's actually a double angle for cos. So I'm actually just gonna use the third version, which he says 1 minus 2 sine squared of theta. So this would be 1 minus, so this would be 2. Of course, sine is opposite, of course, over the hypotenuse. So this would be -3 divided by, that's 5. But we square that. So we know that, of course, when you square -3, so this would be 9 divided by, of course, that would be 25. But of course, 9 multiplied by 2, so this would be actually 18. So let me just do that on the next step. So that would be 2. So we have a 1 there. So if we simplify that further, you're gonna have 18 over 25. But we still have that 1 minus, so still have 1 minus that. So of course, if you simplify that further, you're gonna get I think that's 7, because 25, of course, minus 18, that's that you would get 7 over, of course, it would be 25. So that's the value that you're gonna get when you simplify that. So that's 7 over 25. So they say that of course, they want the value for tan of 2 theta. Now we don't have a double angle identity for tan, but what you should remember from, of course, last year is that when we have tan, we can change that to sine over cos. So in this case, so we're gonna change that tan of 2 theta to sine of 2 theta minus, of course, divide rather by cos of 2 theta. So this would actually change to so this would be sine of 2 theta all over as cos of 2 theta. Of course, we had there is a double angle identity for 10, but it is no, we don't, it is not actually in the curriculum. So in this case, so there is it is there. If you want, if of course you want to know it, it is there. There is a double angle identity for 10. But what we do actually in grade 12 is that we change that 10 of 2 theta to sine 2 theta over cos of 2 theta, because we have the double angle identity for sine, and so do we have the, of course, the double angle for cos. So in this case, if you know, I'm just gonna bring that down there so that I don't squeeze myself in there. So in this case, sine of 2 theta, so this would be actually 1, so this would be actually 2 sine of theta multiplied by cos of theta, that we divide by 1 minus. Of course, you can use the other version for cos. Remember, we have 3, so this would be 2 sine squared of theta. So what I'm actually going to do now, remember we actually found the value for the double angle of sine. So in this case, this would be 24 divided by 25, and that would be all over. So that we found to be 7 over 25. Let me just put that equal down there. So in this case, so this is, of course, if when you change that, this would be 24 over 25 multiplied by, of course, 25 over 7. So that would actually cancel. So this would cancel with that, and you'll be left with, of course, that would be, let me just bring that up there. So this would be actually 24 divided by 7. So that would be the final answer. Of course, the value that you're gonna get, of course, but for 10 of 2 theta. So that's how we would answer that question. So we have 3. There are 2 more to go. So that we still have 2 more questions that we're going to do. Again, you can hit pause. You try it out, and then, of course, you can watch the solution. Now they say that if of course sine of alpha is equals to 3 over 5, that's 3 over 5 there. I kind of made a mess. So they say if sine of alpha is equals to 3 over 5, with alpha being of course an element between 90 and 270. So I'm just going to use this first diagram here. So in this case, and between 90, so this would be 90, this would be 180, this would be of course 270, and that would also be, that's 360 or 0 there. So they say of course alpha is between 90 and 270, so it can either be on this quadrant or of course in the third quadrant. Now the other information, now remember that now sine, they say sine of alpha is equals to 3 over a 5, right? So in this case, so we can see that actually that ratio there is positive, and we know that sine in this second quadrant it is positive. So this is where we are actually going to draw our diagram for that, for sine alpha. So this, so that this angle here would be our alpha, so that would be 90 there. So again, we know that sine is opposite, so this side here would be of course our 3, and this would be a 5, the hypotenuse. And of course to calculate the x, would use the Pythagoras theorem, which says of course r squared is equals to x squared plus y squared. But we must not forget to give credit to Mr. Pythagoras. So this would be Pyth. So of course r squared, that would be 5 squared, which is actually a 25. That would be equals to x. That's what you are looking for, right? So the y in this case would be a 9. So it would be 9 squared. So it would be actually 3 squared, which would be a 9. So 25 minus a 9, you get that to be 16. And of course, if we square that, you'd get x to be plus or minus a 4. So we know that of course x in on this region would be negative, so this would be actually a negative 4. So that that would be of course for sine of alpha when of course alpha is between 90 and 270. And then they also say that cos of beta is equals to 12 over 13. Now they say beta in this case is an element between 180 and 360. So in this case, so we know that this is 180, so that's 270, that's 360 there. So they say it is between of course 180, so it can either be on this quadrant or on that one. But again, we can see that that ratio there is positive. So in this case, what it would be of course in the fourth quadrant. So in this case, this is where we have the most dots. So in this case, this is where we're going to to draw our triangle. So we have of course that's 90 there. So we know that cos, that's the adjacent, which will be 12, and then the hypotenuse in this case would be of course the 13. And of course to calculate that there, you still use the Pythagoras. Let's just do that. So 13 squared, in this case that's 169, and then 12, so this would be equals to of course 12. We know that that's 144 plus of course y, that's what we are looking for. So in this case 169 minus 144 minus 144, that would give us 25, and then the square root of 25, that would be of course 5, but it would be positive, it would be plus or minus of course 5. But in this case we know that 5 the y on this region would be negative, so this would be actually a negative 5. So in this case our y would be a 5, minus 5 rather. Now we can proceed in answering the question. This is determine the value of each of the following without the use of a calculator. Now they say of course they want the value for sine of alpha minus beta. We can see that's an identity. So what I'm going to do, I'm going to expand that. So this would be actually a sine, so this would be sine of alpha cos of beta minus that would be cos of alpha multiplied by, of course, sine of beta. So that's when we expand there using the compound angle, the compound angle identity, of course, for sine. So of course, sine of alpha in this case would be 3 over 5. So this would be 3 over a 5. And cos of beta, this would be 12 over 13 minus cos, of course, of alpha. In this case, we know that cos is the adjacent over the hypotenuse. So this would be actually negative a 4 over a 5. And of course, sine of beta would be, of course, it would be the opposite. So this is where our beta is. So this would be, of course, negative 5 divided by 13. So that what you would get there when you put those values there. So in this case, so this of course 3 times 12, that's 36. So this would be 36. So this would be 36 over 5 times 13, that would be 65. So minus, of course, these two again would give us 5 multiplied by 13. This would also be 65, but the numerator in this case would give us a 20. And of course, if you put those together, you'd have 65 being the denominator, and of course the numerator in this case would be 20. So it would actually be 16, because we know that 36 minus 20 would be 16 there. So this would be the value of sine of alpha minus beta. So the first step that we did was to expand that, and then we just put the value there and simplify. As of course we go to that answer there. So they say of course that they want the value for cos of alpha plus beta. Again, this is a cos compound angle identity, so we can expand that to cos of alpha multiplied by cos of beta minus this will be sine of alpha multiplied by sine of beta. So what we would do, we know that cos of alpha, so this would be, so cos of alpha, we got that to be negative 4, right, over a 5. So this would be negative a 4. Of course, you can still use the diagram. So this would be negative 4 over a 5. And cos of beta, we got that to be, this was 12 over 13. So this would be 12 over 13 minus sine of alpha. Again, that was 3 over a 5. And of course, sine of beta, in this case, this was negative 5 over 13. And from that step, we know that, of course, 4 multiplied by 12, this would be 48. So this would be negative 48 over 5 multiplied by, of course, 5 multiplied by 13, this would be 65 minus, of course, this would be 15. We know that, so this would be 15, but now we know that a negative and a negative give us a positive, so that would change to a positive there. 5 times 3, again, that's 65. And of course, when you put those two together, what you would get would be 16. Is that 16? That's actually 13. This is 13 over, this is actually 33 over 65. So that would be the value that you get there. Of course, for cos of alpha plus beta, again, you first expand that, acknowledging that's actually a compound angle identity for cos, and then now you just carry on by putting in the values. So we have, of course, the last question that we're going to do. They say that if sine of 12 degrees is equals to k. Now this is a typical exam question. I've seen there are questions like this in the exam. What I'm going to do is that I'm just going to produce another video dedicated on the questions that that show up in the exams. So I would say watch out for that. Of course, they say if sine of 12 is equals to k, determine the value of each of the following without the use of a calculator. Now again, they didn't give us any more restrictions in this case that k 12, let's say 12 degrees is between this range and that. So what you're going to do in this case, just draw a random right angle triangle. So I'm just gonna put it. It doesn't actually look like it, but anyway, I'm sure you can see what I'm trying to do. So what we have here, we have 12 degrees, so this would be 90. So that would be 90 there. So of course they say sine of 12 is equals to k. So we know that that is a fraction. It will be 1. It will be k divided by 1. In this case, the hypotenuse would be 1. And of course, the opposite would be k, and the adjacent in this case, it will be just, if you use the rule of Pythagoras, which says r squared is equals to x squared plus y squared. So in this case, if you do that mathematical gymnastics, you're gonna get 1 minus k squared, but you square, you put that under square root. Again, of course, if this is 12, that's gonna be 78. So in this case there, so we can proceed to answer the question. So what I would actually advise that you do is that make sure that of course your triangle has the most information. So if of course they gave us that, you would find the third angle, and of course you must just make sure that you have all the sides in this case, just in case they ask it. So in this case, they say they want a cos of 24 degrees, but we can see that we have actually 12 and 78. We do not have 24 in that diagram, but what you can see is that 24 is actually double of 12 degrees. So what you can do is that you can actually rewrite that 24 as, so I'm just gonna write that 24 is cos of 2 multiplied by 12. So in this case, I'm just gonna make that a double angle identity for cos. So which says just gonna take the third one again. So this will be let me just take the second one for the second one for a change. So this would be 2 cos squared, of course, of 24. Also, actually, this will be 12. Yeah, I'm writing a mess there. So this will be 2 cos squared of 12. Of course, we negative 1 there. We subtract a 1. So in this case, we know that of course we know the value for sine squared of 12, of cos squared of 12 in this case, because if we are standing there, we know that the definition for cos would be the adjacent over the hypotenuse. So this would be 2. So in this case, that would be just 1 minus k squared. Of course, we subtract a 1 there. So this would be, of course, the value of cos of 24 degrees. So what the first thing that you needed to acknowledge there was that 24 is actually a double of 12 in this case. So you can just all you needed to do was to change that 24 to 2 multiplied by 12, and then you just use the double angle identity version to expand that. So in this case, they say that they want the value for sine of 42. Again, you can see we don't have 42 there, but again, what you need to ask yourself is, can you rewrite 42 with what you are given right now and what you know? Of course, we know the information for the the special angles. We know that we have 30 degrees, and also we have 45. And we have 60. We know the values of all of those special angles, and also we know that we would also have 90 in this case. So again, you ask yourself, is there a way to rewrite 42 using what we already know from this point? So we know the values of that, and we also of course know the value of 12 degrees of course in that diagram. So in this case, what you would actually notice is that 42 in this case, 42 would be the same as 30 plus a 12. Now, why am I gonna use that? Because I know, of course, the information for 30 degrees. Of course, I know that's a special angle, and of course 12 would be, of course, what I'm given there. So in this case, I'm actually just gonna change this 42 to being a sine of 30 plus a 12, because I know everything of sine of 12 of 12 degrees, and I know everything, of course, for 30 degrees. So in this case, what I'm going to do, I'm just going to expand that using the sine compound angle identity. So this would be sine of 30 degrees multiplied by cos of 12 degrees plus this would be cos of 30 multiplied by sine of 12 degrees. So again, we know that sine of 30, that's a half, and cos of 12 would be, again, so this would be 1 minus k squared. So this would be, again, plus cos of 30, that's root 3 over a 2, and the sine of 12 that was given to be k. Again, what you can do is that, you can just, add those two. So if you add those two, what you would get actually would be, so in this case, I'm just gonna make that to be 1 minus k squared over a 2 plus root 3 k, of course, over a 2. And of course, if you add those up together, you'd have 2 is the denominator, because it is the same. So you would have actually that root 1 minus k squared plus root 3k. So this would be, of course, the value for sine of 42 in terms of k. I should have actually just mentioned they determine the value of each of the following in terms of k. But of course, they say they want the value of sine of 78. Of course, we know that we have 78 in our diagrams, in this case. So this would actually be a sine. Sine of 78 would be, actually, we know that sine is the opposite, right? So in this case, this length here, which is root 1 minus k squared, that would be the opposite, and the hypotenuse would just remain the same. So this would be 1 minus k squared, and we divide that by 1. So the value for that would just be root of 1 minus k squared. So that would be the value, of course, for sine of 78. So the one thing that I can advise you to do is that always make sure that you have all of those angles. In this case, if they gave you one, of course, you can be able to find that, and you must just make sure that you have all of the sides, so that if, of course, you can see that sine of 78 degrees we didn't have initially, but we got that to be 78. So this is of course the end of today's lesson. So I just wanted to to cover this Pythagoras type questions, I call it, so that because I've seen that they do come up a lot in exams. So what I'm going to do next is that I'm going to to produce another video dedicated on the type of questions, of course, that come in the exams. So watch out for that. Now, if, of course, if this video helped you, you can always share with your friends, and of course, if you have any question, you can always just throw it in the comment section. But for today's lesson, this is the end for today's